Ever wondered how your Wi-Fi network keeps hackers out? With so many authentication methods out there like WEP, EAP, and PEAP, how do you know which one is truly secure? In this video, I'll break down the most common wireless authentication methods from the outdated WEP to the robust EAP-TLS. Learn how to protect your network from unauthorized access and keep your data safe. Whether you're a network admin or just a Wi-Fi user, this is your guide to bulletproof authentication. Ready to secure your network? Let's dive in. There are many different methods for authenticating wireless clients when they try to connect to the network. These methods have evolved over time to address certain security weaknesses. In this course, we'll look at the most common authentication methods you might encounter. At the very beginning of the 802.11 standard, there were only two authentication methods: Open Authentication, WEP, Wired Equivalent Privacy. Open Authentication lives up to its name. That is, it's open access to the wireless LAN. The only requirement is that the customer must use the 802.11 standard to be able to associate with the access point, and that's it. There is password nor identity checks. Seen like that, it's true that it doesn't seem very secure. But in fact, the main purpose of this method is to validate that the customer has 802.11 compatible equipment. As for the identity of the customer, well, it will be verified by other means. For example, in public places, such as at the airport or even in hotels, you can freely hang the Wi-Fi terminal. And as soon as you open your browser, well, that's when you are asked to accept the terms of use of the Wi-Fi and to authenticate yourself before being able to access the network. As you might expect, Open Authentication offers no security on the encryption of data between the client and the access point. This is why the 802.11 standard defined WEP as a method of making a wireless link close to a wired connection. WEP uses the algorithm RC4 encryption system with the aim of hiding the data circulating in the air so that it is not listened to. This is called the WEP key. WEP is known as a shared key security method. That is, each client and AP must share the same key in order for the client to associate with the AP. The WEP key can also be used as an authentication method and as an encryption tool. In this case, the access point will test the WEP key client, sending it a random sentence to test it. The client will encrypt this phrase with its WEP key and send the result back to the access point, which can compare the client's encryption with its own to see if the two WEP keys give the same results. WEP keys can have a length of 40 or 104 bits, which is a string of 10 or 26 hexadecimal characters. As a general rule, the longer the keys, the stronger the encryption. But this is not the case for WEP. WEP became part of the 802.11 standard in 1999, and it was shortly after, in 2001, that a number of weaknesses were discovered in the WEP. It was therefore necessary to find a new plus effective method to secure wireless networks. And it was only in 2004 that Amendment 802.11i came out, and the WEP officially lost popularity. That's why today WEP encryption is considered as a weak method to secure a wireless LAN. With only Open Authentication and WEP available in the original 802.11 standard, the more secure authentication method. So rather than adding new authentication methods to the 802.11 standard, a new, more flexible and scalable structure has been created. This is the 802.1x standard and is based on the Extensible Authentication Protocol, EAP. The 802.1x standard is a security solution developed in June 2001 by the IEE to authenticate a user wishing to access a network, whether wired or not, thanks to an authentication server. 802.1x is based on the Extensible Authentication Protocol, EAP, defined by the Internet Engineering Task Force, IETF, whose role is to transport user credentials. The EAP protocol works based on the use of a gatekeeper, authenticator, which is responsible for establishing or not establishing access to the network for a user. Supplicant. You have to see the gatekeeper as a simple gatekeeper that serves as an intermediary between the user and an authentication server. In the case of a wireless network, it is the access point that plays the role of gatekeeper. The authentication server is used to validate the user's identity, which the network controller has passed to the user, and he will return these own rights to him. Typically, a radius remote authentication. Dial in user service. Server is used as the authentication server. We will now look at the different authentication methods of the EAP protocol. In an attempt to address the weaknesses of the WEP, Cisco has developed a wireless authentication method that can be found with the initials of LEAP, lightweight EAP. To authenticate, the customer must provide a username and password. The authentication server and the client. Encrypted challenge messages are exchanged. These are encrypted sentences sent to validate mutual authentication. As long as these test messages can be successfully decrypted, the client and access point will remain authenticated. The problem is that this method was deployed at a time when WEP was still very widely used, and LEAP has tried to overcome the weaknesses of WEP by using dynamic WEP keys that changed very frequently. In addition, and this is the biggest problem, is that the method used to encrypt the messages of challenge have found themselves very vulnerable. This is why the LEAP is strongly discouraged. So even if wireless clients and controllers always give the possibility to use this method, well, it is better to take another one. Subsequently, to overcome the weaknesses of the LEAP, Cisco developed an even more secure method, which is EAP-FAST, EAP Flexible Authentication by Secure Tunneling. Here, the credentials are protected by transmitting access protection, which can be found under the initials PAC, Protected Access Credential, between the SA and the requester. PAC is a form of shared secret that is generated by the access point and used for mutual authentication. This method is a sequence that takes place in 3 phases. To begin with, the PAC is generated and installed on the client. Then, once the client, supplicant, and the authentication server have identified each other, they will negotiate a TLS, Transport Layer Security Tunnel. And finally, the end user can then be authenticated through this TLS tunnel for added security. As with other EAP-based methods, this requires a radius server, which must function as an EAP-FAST server in order to generate PACs per user. Now let's move on to the next method. As with the previous one, the PEAP protected EAP uses an authentication server, except that the authentication server will present a digital certificate to identify themselves to the customer. And if the client is satisfied with that identity that the authentication server has provided, well, both will build then a TLS tunnel that will be used to identify the client and exchange encryption keys. So note that only the authentication server has a certificate for the PEAP method. This means that the client can easily authenticate the AS. The client does not have or use its own certificate. It must be authenticated in the TLS tunnel using one of these 2 methods. A PEAP method in Microsoft version, MSCHAPv2, Microsoft Challenge Handshake Authentication Protocol version, and the GTC, generic token card, method, which is simply a Cisco version. And the last EAP method is the one that uses the Security Transport Layer, TLS. It offers good security, as it uses 2 certificates for the creation of a secure tunnel that then allows identification, a server-side certificate, and another customer-side. This means that even if the password is discovered, it won't be of any use without the client certificate. So even if it provides enormous security, the problem is that all customers must have a certificate, which can be difficult and expensive to manage one certificate per machine for companies that have a lot of machines.